This is AQA GCSE Chemistry. It is from the Trilogy 1H higher paper from 2018, and this is question 7. The whole question is available to begin, so you can pause as you go and then review. This is 7.1, and this is 7.2, with 8 marks available in total. So for question 1, it is a 6 marker. You've been provided with some information about what happens to 4 unknown solids, A, B, C, and D. And you've also been given the names of the 4 compounds and information about their solubilities. Now, as a 6 marker, we follow the usual levelled response, and you can see that here. But the indicative content on this one, first of all, you've got to recognise which is which. A is sodium oxide. Now, sodium oxide, very soluble. We know that metal oxides are bases, and sodium oxide goes on to make sodium hydroxide. Now, we would expect that to be a strong alkali because it is so soluble. So A, sodium oxide, for that reason. When we move down to C, we've got magnesium oxide. Now, magnesium oxide is also a base. It's a metal oxide, but you can see it's far less soluble. So it's not going to make a base as strong. So we're looking at a pH of only 9, slightly higher than neutral. Silicon dioxide has absolutely no solubility, so we wouldn't expect, well, we would expect a colourless liquid, we would expect solid remains because the silicon dioxide stays there, and the pH wouldn't change. We're still measuring the pH of water. And that leaves us with our phosphorus oxide for B. Now, non-metal oxides are acidic. Think about sulfur dioxide causing acid rain, and you get to remember, hopefully, the remainder of the pattern. It's fairly soluble, so we're seeing the pH go below 7. It goes to pH 3. On to 7.2. 10 cm cubed of solution B is added to a beaker. Distilled water is added to the beaker until the final volume is 1000 cm cubed. The pH of the solution is measured before and after distilled water is added. Table 4 shows the results. Calculate the value of X. There's a really important piece of information that you have got to remember about the pH scale. And that is, for every change, pH of 1, the concentration changes by a factor of 10. So if I go from 1 to 2, I am diluting an acid by a factor of 10. So if I change it by a factor of 2 and I go from 1 to 3, I'm changing by a factor of 10 times 10. It's changing by a factor of 100. It's a logarithmic scale. So what we've then got to do is look at the volume. If I've gone from 10 cm cubed and diluted it to 1000 cm cubed, I am going to expect my pH to change by 2. I also know, because I'm diluting, I'm going to go weaker. I'm going to go close to neutral. So for that reason, we can say that the pH in this circumstance would go from 3 to 5. And that takes us to the end of question 7.